What is Dijkstras algorithm? It is one of the most commonly known shortest path algorithms. It was developed by a Dutch computer scientist, Edgar W. Dijkstra, in 1956. The need for Dijkstra's algorithm arises in many applications where finding the shortest path between 2 points is crucial. For example, it can be used in routing protocols for computer networks and also used by map systems to find the shortest path between starting point and the destination. First of all, it is important to know that Dijkstra's algorithm can work on both directed and undirected graphs. Given on the screen is the Dijkstra's algorithm through which we will be able to solve problems. To sum it up, the algorithm maintains a set of visited vertices and a set of unvisited vertices. It starts at the source vertex and iteratively selects the unvisited vertex with the smallest tentative distance from the source. It then visits the neighbors of this vertex and updates their tentative distances if a shorter path is found. Now this process continues until the distance vertex is reached or all the reachable vertices have been visited. A code for Dijkstra's algorithm is displayed on the screen, which helps us find the shortest path possible.
Now, as you know what is Dijkstra's algorithm, I'll be telling you the method and the approach, how to use it to solve different graph problems as well as real life problems. It uses a method called greedy method in which we go step by step to approach the problem and which is used to provide the optimal solution for the problem. I'll be explaining you by this simple graph. This is a simple graph consisting of three nodes 1, 2 and 3, which has three edges of different values. Dijkstra's algorithm has a basic relaxation condition, that is du plus cuv is less than dv, then the value of dv becomes du plus cuv. That is basically the sum of the above two. Above condition becomes the value of the dv. Now in the graph, let us consider the value of 1, 2 and 3, the initial value. For second and third node we consider it infinity, and as the source vertex is 1, we consider at 0. U is the initial position and V is the final position for first and second node. Now if we use the relaxation condition, du for one node becomes 0 as we are standing on it, that is the initial point, and c uv means the cost of u and v, that is our first point and the second point, that is 20 given in the question itself, which is less than the value of dv that we set as infinity in initial. That is the if the condition is true, and as we can see the condition is really true, the value of dv becomes 20. Similarly, now if we go first to third directly, the value we set for du is 0, that is same, and cuv is 40, and the third as set initially, that is infinity, dv becomes 40. Now if we go and indirectly, that means passing through to second node, we have to cross the second node to go to the third node, then the value changes. The second node becomes the initial node and the third node becomes the final node, that is u and v. For second u it becomes 20 as we find out through this, and the cuv is given 10, which is less than 40 as we find out from here. So the value is correct as the condition is fulfilled, the dv becomes 30. As this method is single source shortest path, we consider the value of 30 and not 40 because that is the alone shortest path and completes all the relaxation equation, and the single source shortest path algorithm is solved for this small graph. Now this is a particular example of graph that is undirected. We have to solve this using Dijkstra's algorithm. First, there are 6 nodes we have to identify, and there are so many edges with different counts. Okay, we have to differentiate between source and destination. We'll be taking one for the source and others as destination. So we'll make a table with one source and other destination. 1 will be 0, as initially we are standing on 1, the value of 1, the cost for 1 will be 0. Then for other destinations we don't know the value, so we'll set them as infinity, 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 infinity. Now we are standing at 1, we'll see the nearby nodes or nearby vertices one by one. 1 to 2, the value is 7, so we'll write 7. 1 to 3, the value is 9, so we'll write 9. And 1 to 6 is the value 14, so we'll write 14. As 4 and 5 are not directly approachable, so we'll write infinity only. Now we'll see which among them is the shortest and the smallest value, 7. So we'll circle it. Now 1 and 2 will become the source, or we can go through them. So we'll put 2 out and we'll put the 7 circled value in the line also. Now 7 circled value is here, 1 and 2 is the source. For 1 and 2, we'll see now we can approach 4 while going through 2. The value of 4 is 7 and 15, that is 22. We cannot approach 5 again, so we'll copy infinity, and 6 it will be 14 only. We'll copy the 1 and now we'll see the smallest one. 7 is already circled, so we'll circle 9, and now 3 will move to the source side. Now we can see that we'll copy 7 and 9. This 22 becomes 20 because now we have two ways to approach to 4. 1, 2, 4 and 1, 3, 4. 1, 3, 4, the value is 9 plus 11, 20, and 1, 2, 4, the value is 7 plus 15, that is 22. So we'll write the shortest value 20, and again 5 is not approachable, so we'll copy infinity only. And 1, 3 and 6, the value of 6 earlier was 14 because it was directly approachable, but we have to find the shortest value. That is what the basically point of Dijkstras algorithm is, right? One source, shortest path. So 1, 3, 6, 9 plus 2, 11. So we'll write 11 and we'll compare all the above and circle the smallest one. Then now we'll put 6 out in the source, and now we have access to fifth also. So 7, 9 are already circled, 20 is already circled, and 20 is not circled. 6th is circled, so 6th is outside in the source. And now we'll copy the fifth one also because we have access to the fifth one also, that is 20. So 20, 20, both the values are same. We can take either 4 or 5. So I'll be taking 4. I'll circle to 4 and then 4 becomes in the source. 4 comes out. Then the last one becomes 20 of for 5. Then I'll circle this. Then 5 comes out. So this is how a particular undirected graph problem is solved using Dijkstras algorithm by using the greedy method. Thank you.
So now I will be explaining about the time complexity. So we are using a graph and a source. So this is our graph, which we have taken a smaller graph for our better understanding, and we have taken this as our source. So now this the code is, the algorithm is create vertex set q. So now we have created a set as q in which all the vertices are included, in which set q all the vertices are there. For each vertex v in graph, distance v is equal to infinite. Add v to q. Distance source is equal to 0. So now we have taken the distance of source as 0 because the time it will take for the source to come to the source will be 0. So now we have taken all the distance of v as infinite. So we will take this as infinite. So now what we will do is add v to the q. So now here we are building a heap. In heap also we are building with the function as minimum, so that we can understand our time complexity. So now while q is not empty, u is equal to extract min q. So now we are taking a value of u which would be the minimum value in this q. So this is a Q because it consists of all the vertices. So now this as S we are taking it as the minimum value. So now the for each neighbor V of U, relax UV. So now here these are the neighbors of U. So now the distance of this will be 10, and it is lesser than infinite. Yes, it is lesser than infinite. So the value will be 10. Here also it will be 20, and here will be 30. Now again we'll repeat U is equal to extract min of Q. So now from here the minimum value will be this one. So the neighbor of this is this. So what will be the value of this? The value of this will be 10 plus 40, which will be 50. So now again we'll come into U is equal to extract min Q, which would be this one. The value would be 20 plus 50, which is 70, which is greater than 50. So that means that it will remain as 50. Then 30 plus 60, which is 90, which is also greater than 50. So it will remain as 50. So now we have created this. Now we'll talk about the time complexity. So from this part, we can understand that the time complexity is order V, because we are repeating this program V times. So it will be written as V. Now we are taking it, add V to the Q. We are adding V to the heap, to the set Q. So the time complexity for that will also be order V, because we are repeating it as V times. Now U is equal to extract min Q. So the time complexity of this will be order log V. But how many times are we repeating it? We are repeating it as V times. So the time complexity will turn out to be V log V. Now relax UV. So for this one, how many times the complexity would be same as log V. But how many times are we repeating it? We are repeating it. It depends upon the edges. So it will be E log V. So this. So now the total time complexity would be the value which is most dominant. So from here, these are lesser values, and these values log V and log V are same. So there's a comparison between the V and the E, and we know that the edges are more than the vertices. So now the time complexity turns out to be E log.